Welcome. In this video, we are going to discuss some results. The first result says that if x bar is the mean of a random sample that we have taken, which is of course size n, from an infinite population. Okay. So when we say infinite population, it means the population has a very large quantity. It is not the actual infinity. Basically, this infinity is a very large quantity that one cannot count or measure. Okay, so it means we have taken the sample from a very huge population with mean mu and variance sigma square. Okay, so we say that expectation of x bar is same as that of the mu and variance of x bar is same as that of sigma square upon n. How are we going to prove it? Okay, so the proof is as simple. Let us have a simple look at it. So expectation of x bar, is it what? It is expectation of x1 plus x2 till xn upon n, isn't it? So this n is constant, so we take it outside. So we have expectation of x1 through xn. And when we collect a sample, we have something in us. What is it? These samples should be independent. So it is 1 upon n times of expectation of x1 through expectation of xn. Now that each of this random variable are taken from the population with mean mu and variance sigma square. So it is 1 upon n times of mu till mu for n times. So it is n mu upon n, which is mu. Okay. In a similar fashion, let us consider variance of x bar, that is variance of x1 through xn upon n, isn't it? So this n is a constant, so we take it outside. N square. This is what we are going to get, isn't it? Okay. And here we would have variance of x1 through variance of xn. So it is going to be n times of sigma square upon n square, which is sigma square upon n. So even for an infinite population, if we take a random sample, we are able to find out this mean is going to have the mean, the sample mean is going to have the mean mu, the expected value mu, and variance sigma square upon n. This is the first result. Okay. And once you have the variance, you can very well find out the sample standard error, right? Standard error of sample mean is sigma upon under root n. The next result is known as central limit theorem. Suppose you have the sample mean of a random sample of size n taken from some infinite population with mean mu and variance sigma square. Then with this, you know the expected value and standard deviation of this thing, with which you can normalize it. Okay, so that becomes a standard normal variate in the distribution as n approaches infinity, which means what? When your n is getting larger and larger, you can convert this to a standard normal variate. Okay. So now we have some note based on it. This result too, the conversion of standard normal variate can be used when n is large. That is when your sample size is bigger than or equals 30. Okay. If n is large and when population standard deviation is unknown, we use, that is if sigma is not unknown, we can use the sample standard deviation as an approximation to sigma. Okay, now we have a problem. It is given that random sample of size 64, okay, is taken from some large population with mean 76 and variance 9. Now that we are asked to calculate the probability that the sample mean will lie between 75 and 77. So first of all, what are the information given to us? The sample size is 64 and population mean is 76 and variance is 3. Variance is 3. Right? Okay. So, sorry, variance is 9. Therefore, standard deviation is 3. Fine. Now we need to find out the probability that the sample mean is lying between 75 and 77. This is what we need to find out. Okay. It is same as the probability that it is 75 minus mu upon sigma upon under root n less than x bar minus mu upon sigma upon under root n less than 77 minus mu upon minus mu upon sigma upon under root n. Why are we doing it? Because for the population, this is the for x bar. Okay, for x bar, this is the mean and this is the standard deviation. That is why we are using those quantities to calculate all this stuff. So it is probability of 75 minus 76 upon 3 upon under root 64 less than this one is simply z 77 minus 76 upon 3 upon under root 64. Okay. After performing some suitable calculations, what we get is probability that it is lying between minus 2.67 and 2.67. Okay. So it is completely up to you to decide which standard normal table you are using and with which you can very well calculate this as the probability 0.9924. So with this probability, our sample mean is going to lie between 75 and 77. Okay. Moving further, we have another result. X bar is the mean and S square is the variance of a random sample from a normal population. So from a normal population means the population is following normal distribution with mean mu and variance sigma square. Then with this, okay, with this t equals x bar minus mu upon s upon under root n, this is the student's t random variable with parameter n minus 1. The parameter is denoted as nu, which takes the value n minus 1. Okay. Now that we are defining some other random variable or some other density of a random variable by this means. Okay. So, when are we going to make use of this result? That is student's t random variable. This is used when your sample size is smaller than 30. Usually a sample size which is smaller than, which has only less than 30 samples is considered to be a small sample. Okay. So in this case, population variance is unknown and population is normal. Okay. And the student t distribution is also kind of symmetric to normal with the one thing. Okay, when we deal with standard normal, there we have the variance which is 1 and mean 0. Whereas in students t, mean is 0 but variance is something bigger than 1. Okay, but still it has also a bell shaped curve which is symmetric about origin. Okay, and what if the parameter nu is bigger than or equals 30? In this case, your student t distribution can be approximated with the help of standard normal itself. Okay, and this one t student t distribution with parameter, this thing is denoted as t alpha, where this t denotes it is following students t, it is a student t random variable. This alpha is the level of significance. Okay, so we need to read, we have a table for this t distribution as well. We'll have to read the values from it. Okay, and when the population is normal and if we know sigma value, then there is no harm. When we know the sigma value from the population, for every n, standard normal will work. Okay, when we don't know the variance of population, then we'll have to carefully choose whether to use student t or standard normal. Okay, now that we have a table, suppose this t alpha, let us fix alpha as 0.05. Okay, now you this new, okay, this is what, this is n minus 1. Now suppose I am asking, okay, so this alpha is the level of significance and nu is the degrees of freedom, or the parameter which takes the value n minus 1. Okay, this t alpha is going to give you some probability, some value that is found in the inside of this table. Okay, this nu is this is known as degrees of freedom. That is found on the left side, that is found on the left side of the table over here. Okay, and now this, as I said, this alpha is the level of significance. So this level of significance is specified as we need 95 percentage confidence at the level of significance of sometimes it is said that 5% level of significance, which means we can neglect this 5%, which means we need 95% confidence. Okay, in these two cases, either if it is set 5% level of significance or 95% confidence, both this means your alpha is 5%, that is 0.05. Okay, and this thing is available on the top, on the first row. Okay, so these are some standard values. In the problems that we are going to deal, we will be given with these values only, mostly nothing else would be given. Okay, suppose you are going to find out t of 0.05. Okay, when your n is 15. Okay, this is what you are asked to find out, which means what is your degrees of freedom? That is n minus 1, 14, isn't it? So you have identified 0.05 here, and you need to look for 14. So the common value, this is the value. So your t of 0.05 is 1.761310 for this many degrees of freedom. Sometimes in a problem, we may be in a situation to find out t of alpha upon 2, where alpha is the level of significance and nu is the degrees of freedom. In this case, what is going to happen? Your alpha is 0.05. So you need to find out. Okay, that one, let me write it in different color. So in this case, you need to find it t of alpha upon 2, where your alpha is 5% and your nu is, let us have it is some 12. Okay, let us have our n to be equal to 12, so it is 11. Okay, alpha is 5, but alpha upon 2 only we are going to find it out, so it means 0.025, and that is over here, right? And what is new? It is 11 now. So this is the value that we need. So t of 0.025 is 2.2099 for nu equals 11 degrees of freedom. Okay, let's move further, and this is talking about some statistical inference that we will deal in the next video. Thank you.